Hello viewers, in today's session we are going to discuss another important conceptual problem from continuity of functions related to greatest integer function. So here we are going to discuss one important problem where we have to discuss the continuity of this function f of x, which is equal to greatest integer of x minus 1 at x is equal to minus 3, right? And here we can see that we have to discuss the continuity of this greatest integer function at this integral point, that is minus 3 is an integer, right? So let us start. So to discuss the continuity of a given function at some given point, what we do, we find out the right hand limit, and then we find out the left hand limit, and then the value of the function at the given point. So here if we take the point in general as x is equal to a, then we find f of a. And if these three quantities exist and they are finite and equal to each other, then we can claim that the given function, say y is equal to f of x, is continuous at x is equal to a. So the right hand limit, the notation for right hand limit is limit x tends to a. Here we put a positive sign. This is f of x, and then the left hand limit has the notation limit x tends to a minus. Here we put a negative sign, and here we have f of x, and this is equal to f of a. So in this problem we'll find out the right hand limit, then left hand limit, then f of a, and then we'll see whether these three quantities exist and finite, and whether these three quantities are equal to each other or not, right? So let us first find out the right hand limit. So the right hand limit is given by a limit, then we have x tends to minus 3, and we put a positive sign here, and the function f of x is greatest integer of x minus 1, right? So now what we will do, here we have x is equal to minus 3. So when we approach x is equal to minus 3 from the right of x is equal to minus 3, we reach a point that is very close to x is equal to minus 3, and this point may be taken as minus 3 plus h, where h is a positive quantity which lies between 0 and 1, and h is infinitesimally very small, right? And similarly, when we approach towards x is equal to minus 3 from the left of x is equal to minus 3, we reach at a point that is minus 3 minus h. So to get the right hand limit, we'll now transform this limit in terms of h by substituting x is equal to minus 3 plus h, where h is infinitesimally very small and it is a positive quantity, and when x approaches to minus 3, then h tends to 0. So the right hand limit is now equal to limit h tends to 0. For limit x tends to minus 3 plus, we can now write limit h tends to 0, and for x we can now write minus 3 plus h, and here we have minus 1. So now we'll solve this limit, and we have greatest integer of minus 4 plus h. So minus 3 minus 1 is minus 4. So this can also be written as limit h tends to 0, and here we can write h minus 4. Now see, whenever we come across with the limits involving the greatest integer function or fractional part function or the signum function, we cannot directly substitute h is equal to 0. So what we will do, see here we have greatest integer of h minus 4. So if we take the real number line, and here we have minus 3 and here we have minus 4, right? So here we have minus 4 plus h, and h is a positive quantity. So when we add h to minus 4, then this quantity, it lies between minus 4 and minus 3, right? So minus 4 plus h is greater than minus 4, but it is less than minus 3. So when we add h, which is a positive quantity, to minus 4, then minus 4 plus h is greater than minus 4, but it is less than minus 3. So minus 4 plus h, it lies somewhere between minus 4 and minus 3. And by the definition of greatest integer function, the greatest integer of minus 4 plus h is equal to minus 4, right? So now we have limit h tends to 0, and here we have minus 4, so this is equal to minus 4. So the right hand limit of this function at x is equal to minus 3 is equal to minus 4. So now let us find out the left hand limit. So the left hand limit is limit, and here we write x tends to minus 3, and we put a negative sign here, and f of x is greatest integer of x minus 1, right? So when we approach towards x is equal to minus 3, from the left of x is equal to minus 3, then we take x is equal to minus 3 minus h, and remember h is a positive quantity and it is infinitesimally very small, and h lies between 0 and 1, right? So when x approaches to minus 3, then h approaches to 0. So let us now write this limit in terms of h, and we have limit h tends to 0. We have greatest integer of x minus 1. X is minus 3 minus h, and here we have minus 1. So we have limit h tends to 0, greatest integer of minus 4 minus h. So minus 3 minus 1 is minus 4, and this is greatest integer of minus 4 minus h, right? Okay. So now again let us consider this real number line, and here we have minus 5. Now see, we have minus 4 minus h, and h is a positive quantity and minus h is a negative quantity. So when we add minus h to minus 4, then this quantity, it lies between minus 5 and minus 4. So minus 4 minus h, it is greater than minus 5, but it is less than minus 4. So this quantity, that is minus 4 minus h, it lies between minus 5 and minus 4, or in other words we can say that minus 4 minus h is lying between minus 5 and minus 4. And by definition of greatest integer function, the greatest integer of minus 4 minus h is equal to minus 5. So now this limit, that is left hand limit, is equal to limit h tends to 0, and here we have minus 5. So this is equal to minus 5, because here we do not have the quantity which depends on h, so this limit is equal to minus 5. So the left hand limit is equal to minus 5, and now the value of the function, that is f of a, that is f of minus 3, is equal to greatest integer of minus 3 minus 1, taking x is equal to minus 3. So we have greatest integer of minus 4. Minus 3 minus 1 is minus 4, and we know that the greatest integer of any integer is the integer itself. So this is equal to minus 4, right? So the value of the function, that is f of minus 3, is equal to minus 4. So, from this discussion, we have seen that although the right hand limit and the left hand limit both exist and they are finite, right? But the right hand limit is not equal to the left hand limit, that is minus 4. That is, right hand limit is not equal to the left hand limit, that is minus 5. So we can conclude that the limit x tends to minus 3 f of x, that is the limit x tends to minus 3 and greatest integer of x minus 1, it does not exist because the right hand limit and the left hand limit are not equal to each other. So the limit of this function at x is equal to minus 3 does not exist. Hence we can say that the function f of x, that is greatest integer of x minus 1, this function is discontinuous at x is equal to minus 3.